Red light on the device. Can everybody hear me out there? Okay. Testing. Can everybody hear me? Okay. Make them both. Press it. Testing. Coming to the speakers. Okay, well, good morning, everybody. It's a pleasure to be here at AIDE 2015. My name is John Schipp, and I'll be giving a talk on some software I wrote called ISLET. So about me, I work at a supercomputing facility at the NCSA, where we have one of the world's fastest supercomputers, and we're at petascale, so very fast. I am a contributor to a number of free and open source projects, including the NetSniffNG toolkit, the Bro project, and Security AIDE, among a few other small ones. And I also run the Open Network Security Monitoring Group with Shane Rogers back there in the blue hat. So it's at the University of Illinois at Urbana-Champaign. If anybody's interested, it is an open and collaborative group without geographical borders. We have meetings weekly. Anybody can attend and join in. And they can participate, and we have guest speakers nearly every week. And we're going to be doing projects, coding, and research in the future. So if you're interested in that, anybody's welcome to join. So the problem. Well, the problem's not as severe as the one she's currently facing, but we do have a problem in training. So typically, I've been to a lot of conferences, and typically what we see is virtual machine-based training, right? So I can give an example is BroCon. We have BroCon, I was a part of that in 2014, where we taught the Bro programming language. And people will package up these VMs and pass it out to all the students. And what happens is these files that contain all this software is very large, it's in the gigabytes. And you have to distribute this away efficiently somehow. However, people pass them around USB sticks or they download them over the network, and that is not a very efficient means of doing it. So what ends up happening is you peg the Wi-Fi, or students have to wait at least an hour or so, from my observation experience, to pass around these USB sticks. So if you have a conference of 200 people and there's 10 USB sticks, you have to pass each one down, copy to each drive. It's not the most efficient way of doing things. In some cases, it works really well, but in a lot of cases, like in the case of BroCon, we don't actually need to do that. There's other ways we can do this. So another thing that happens with training is there's a lot of technical difficulties, right? So when working with virtual machines, you have hypervisor compatibility problems and configuration problems, right? So you have to be able to have the network set up properly. I've had to fix machines for people where they had the wrong bus selected from SCSI to IDE in their configuration file, and they didn't know what to do. They just had a different setting. And you just have to change that so they can boot the VM. But that puts that person or a group of people that have these problems behind everyone else. So, and lastly, for the problems the students directly face is that, besides this being all time consuming, is account management. So, actually this is the admin, I'm sorry, this is the admin portion. So if you do what's also known as Unix, what I call Unix shared system training, where someone actually brings up a live Unix system, creates 100, 200 accounts for each student that wants to do some sort of training, then they have to actually go out and do these things, like they have to create the accounts, create the passwords, and distribute that to everybody, and that actually takes time too. So an example is the Blue Waters training for the supercomputer at the University of Illinois. They do this, and they'll have a class, say 30 students, they want to teach them how to use OpenAAC or OpenMPI, high performance programming, parallel computing stuff. And what they'll do is when they have the class come in, they'll have the admin the night before create a list of all the users, either write a script or do it manually, and the passwords, and they print them out on little pieces of paper, and when the students walk in, they distribute the pieces of paper on the desks, and then they use that to log into each of their accounts, where they have the compiler and the programs they can use to begin with the courses or the lecture. And that takes time too, so we can kind of cut that out by somehow automating all this. And then finally, from the instructor standpoint, what do you do if in your course lectures or in your training event, you build all this material, right? This training material, these exercises, these PDFs or text files. What happens if you distribute this to these people and you actually have an error in it, or you're missing a file? In a lot of these cases, if they're already packaged up and put inside the VM, then everybody's VM is not up to date with the latest, or is incorrect as far as the exercises go. So how do we fix this versioning issue or mistake that can be made with this? Well, one way to do it with VMs is actually having a Git repository, and if you notice a mistake, the instructor can quickly update it and push it up to the top and tell all the users to Git pull it down, or put it on a website or something. However, this creates a temporary break where all the students have to do that, and the instructor has to interrupt and explain how to do this. So that's not the best way to handle it either. So for these few points, I have solutions that I believe are good enough to solve these in a efficient way. So first is the simple one is, how do you stop passing around and or with the actual problem of distributing these large VMs? You simply don't. You don't distribute VMs, right? You don't do it. You don't need to, because there's better technology, or there's a newer technology out there now to replace this. Also, we want to make the participation barrier as thin as possible. So instead of requiring the user to have a hypervisor installed, right? Why don't we require something that's cross-platform, well-supported, and open standard? And the common thing that comes to mind is OpenSSH. You can just remote access to another system, right? You can use it on your cell phone devices, your other mobile devices like your tablets. All those have applications for that. And the last two is automate the account management. Users have the responsibility to take care of themselves, how it goes. Finally, make a way that the instructor can drop. So what this ends up being is, in terms of training, is that we actually take all this stuff, this work that we put on the students, and we transfer to the admins, right? So they're going to do the work. And that's just a summary. So essentially, make something really easy to configure and deploy for the admin, and make something that's very easy to use for the students. And we have this, the isolated, scalable, and lightweight environment for training. So it's a container system for teaching Linux-based software. So now what is it? How does it work? Well, the top level, ISLET is just glue. It's a wrapper around a number of tools. And they work in a way to get them all working together to solve this problem of training. And one thing that ISLET does that's really nice is it's a simple 3-step process to add new training environments for your users. We'll cover that a little bit later. So uses. How can you use this? Well, right now you can use it for event training, internal software training in your organization or company, capture the flag events, and just generally trying out new tools in a containerized environment. If you don't want to install anything on your laptop and you want to try out this new tool, you can just have a container with the tools in it. You can connect to it using the ISLET software, and it can actually launch, and you can be already typing commands with the new software. And development environments. So getting right to the heart of it, real-world use cases. So where has this been used? Well, we launched the precursor at BroCon 14. We had roughly around 50 users, had shell access to what this was known, prior to ISLET, this was known as the Bro Sandbox. And so we have a bunch of people using, have interactive shell access to a file system where they can play with Bro, use Unix commands, explore, etc. And we did this all on a low-end EC2 VM, right? So one of the cheaper ones. Who's also now using it from the original, from the origin of this, has then came some actual really cool real-world use cases, like the case at the University of Illinois using it in their Digital Forensics 2 class to teach software like Volatility for memory forensics and Bro for network security monitoring, Snort, Sleuthkit for disk forensics, etc., etc. FlowCon had a Bro training course that actually used this as well. And they used about 100 users using it simultaneously without issue. And finally, I used it to teach at the UIUC Linux user group and also at the OpenNSM meetings. And one final note for the instructors before we get into the technical section is there's a feedback loop. With these containers and particularly the software that we use for these containers, everything is recorded for the commands typed in and the output of them. So you can actually go through the logs of each user's interactive shell, and you can see where there's mistakes, where they can be improved upon. You can write that down and then reintroduce that information back into the training material. So it creates this feedback loop that can help improve training. All right, for the best part of the talk, the technical part. So what is the technology behind this stuff?
Linux containers. Has anybody here heard of Linux containers? Okay, a few hands. Has anybody here heard of Docker? Okay, same hands. All right, so let's talk a little bit about containers. So, as you can see in the picture at the top, you have virtual machines. And virtual machines work with hardware. They do hardware virtualization. That's the goal of the hypervisor. Well, we term with Linux containers, we're actually working with operating system virtualization, or also called lightweight process virtualization. And the way this works is the kernel has facilities called namespace and secrets, which we'll get a little bit later. And these essentially provide the building blocks to allow you to isolate portions of your environment. And the users cannot tell the difference. Scalability. So with the virtual machines training, imagine teaching 1,000 people. So you have to have 1,000 VMs if you're using that particular type of training. You can tell that's a lot of work. I couldn't imagine how many hours it takes to distribute all that. So it's just not feasible. And in this case, with container training, we can actually do this fairly easily. Which is really cool. It basically scales with the hardware, horizontally with the hardware, or vertically with the hardware, and hopefully horizontally too if I do a distributed setup eventually. These containers are very lightweight. So JEOS is known as our just enough operating system. So it's a very lightweight file system for each container. And this allows you to get near bare metal performance. And the startup time for these containers, so you think just to comparing back to virtual machines, can be up to a minute, right, to turn on a virtual machine. If you guys ever boot up a virtual machine. And containers, they're in milliseconds, right? I think I ran a bunch of tests, which I might have time to show later, and we graphed it in over 100 runs. It was like 40 or 0.4 milliseconds. So, I'm sorry, 0.4 seconds for actually container startup, which is very, very fast. The user hardly notices the difference. And lastly, for the important parts to explain the name, ISLET, the environment portion. So they provide shell access for interactive shell access for the user. So just as if they were logged in their own computer, a Linux machine, or in a VM, they have the terminal, they can type commands, will do the stuff they need, the tool will be installed already because the instructor prior to that created the image for them to use. Also, here's a research moment here. So in this research report, this paper I read from IBM, they did performance testing of containers and virtual machines, and the virtual machine software using KVM, and the containers are using Docker. They did the performance test with every case, nearly every case, the Docker exceeded or equaled that of the KVM hypervisor. There was memory and disk tests in there, so if you have more information, do check that out. So popularity. So for those that haven't heard of this stuff, you probably will soon. It's growing. And I did some when I did this presentation first at Hackathon, I believe it was. I was graphing, I was using Google Trends to figure out the growth of this, and you can see that the stuff, the containers has been around from 2008, but only now, 2014-15, has it continued to grow. And the same with Docker. And Docker has only been around for a few years now. In this case, it says roughly 2013 is when it's really started to grow after that particular period. Well, it's relatively new software. So what else is using this? Well, you have a number of distributions now and tools to actually do all this management of clustered and parallel containers in the cloud. And you have CoreOS, Project Atomic, which is a spin-off of a Red Hat project. It's commercial. And then you also have Google's Kubernetes, which you can use to manage thousands or millions of containers. And again, back to the cloud, there's also a number of people that are hosting all this stuff for you, so you know what we're doing internally. You have OpenStack in your containers, right? That's a big thing now. Heroku and Google Cloud Platform. So now let's get back to the software that I'm using that is actually creating these containers. It's the runtime for containers. This is called Docker. So it's been around for 7 years or so, but it's only now been at the point where it's really easy to use, and that's what's helping with the growth of the technology. So it automates the deployment of Linux containers, right? It just makes it really easy. A bunch of command line tools that say, hey, I want to run a new container. You type Docker run. You type what container you want to run, and then you're inside a container. It's really easy. It also has tools to package up your own containers. You want to create your own, you have a container, you make a bunch of changes to it. You want to take that and package it up into an image that you can then distribute to other people. It allows you to do that. And it provides layers of abstraction. That's why it makes it so easy. You don't have to do all these technical commands to actually create your namespace and C groups. Docker handles it all for you. And one cool thing, everybody's familiar with distributed version control systems like GitHub. Docker has its own called Docker Hub. That's theirs. But you can also run your own internal registry. So you can actually put your container, your images, in the correct terminology in that case, images to the hub, and then your users can pull them down. So finally, what's the technical stuff about these two building blocks? Well, first of all, it's important. There's no spec for Linux containers, right? The way to appropriately say it is Linux-based containers. There's a number of different implementations. Everybody does their own thing a little bit differently. So in Linux, you have, for as implementations, you have LXC, you have OpenVZ, and you have Google Containers, also known as Let Me Contain That For You. And there's a few other ones, Docker, of course. On non-Linux systems, these aren't containers, but they kind of solve some of the same problems. And historically, the BSD systems have had jails. FreeBSD jails, for example, to contain things. Also, Solaris has zones, and AIX has work partitions. And there's probably other operating systems that have their own way of handling this. So just think of like, one way to say is it's a chroot on steroids, right? So what do containers do? Like I said before, they do lightweight process virtualization. Also known, you may come across this as operating system virtualization. And in contrast to virtual machines, they do hardware virtualization. So in Linux kernel 3.8, that was where the patches were finally put upstream, or in the mainline, kernel to say that, hey, we can have all this worked out very well. We're capable of pretty stable. And these two things that we're worried about, the two building blocks, are namespaces and control groups. So namespaces are what actually provide the resource isolation. So if you think about it, you have like a global namespace, right? You run processes, so type PS, AUX, you see all your processes, right? And if you separate that, you divide it, you can have this other namespace, right? And these processes are in this namespace. And like Google Chrome, it could be in this namespace and separate from the other one. So that if someone would run PS, AUX in this namespace, they would not be able to see it from the other. They're completely isolated. The user does not know. And the tools that you run do not know that's in a separate namespace. The kernel handles all this transparently. And now there's a number of different namespaces. There's PID for your processes. There's NET for networking. So you can have a networking interface in one namespace and not in another. So that's really cool. You can also do mount points in different namespaces, so they're separated, and also users. So finally, the other part is control groups. So this is what provides resource constraints and resource management on these namespaces. Processes are assigned to a control group, also called a C group. And this is what allows you to provide limits to the user, or to the processes that are then passed on to the user. An example of this is CPU. You want to allocate all the CPU to the user, right? You can limit that. Or memory. You can say, oh, I want to allocate 256 megabytes of RAM to this particular group of processes in this namespace. So that's what allows you to do the resource management. And it's not magic, right? So prior to all these tools, you can do this from the shell. You don't even have to have everything installed. You can actually just call. You can mess with the proc file system, the virtual kernel file system, and then sysfs to actually create these things, right? You can do it from a shell script. But it's a pain in the ass, and there's better tools to do that nowadays, such as Docker. So container security. So another thing to think about when you have one of these systems, or you're thinking about deploying it for instruction, is what are the security attack vectors and things that could go wrong, right? What do we need to protect? Well, one good rule of thumb is to disable networking unless you absolutely need it when the user connects, right? So they'll connect to a system, and you just want to have the loopback interface, right? So they can't connect out. So that if they're training, they cannot launch attacks as a proxy to other systems on the network or outside of the network. Also, common security procedure, do not run processes in groups, because there can be an exploit and they can break out of the container. So typically keep them as a non-root user. Also, control the CPU and RAM allocation, so some user cannot starve the resources of all the others, right? And some way to do automatic cleanup. How it does that. So, users over time, they just keep building up their containers. Their state's not saved, all their files aren't saved. It's not persistent. They wipe them out after a user set control. And you can use the device map or storage backend. So Docker has a number of pluggable modules that can be used for the creation of the containers and images. And device mapper is one. That's actually in the kernel. That code is in the kernel. You can use tool like DM setup if you don't want to do it manually to limit disk space so that the user cannot like denial of service the system, type yes and redirect the output to a file and let it grow really large. So you can do things like that. And finally, you want to set, as the admin of this system, you want to set fine-grained controls to the environments, right? So limit the file sizes, limit the number of processes in the environment, just so people don't screw things up, right? Or act maliciously and then affect all the users in your training course. Host security. So one thing you can do is apply GR security patches, right, to improve the security of the host operating system. That includes improvements in ASLR and other such things that exploit stacks and heaps and etc. So with that, that's probably one of the best things you can do. Other than that, you can limit for SSHD, because we talked about earlier how to connect to the system. We use a popular cross-platform, proven and tried and true piece of software called OpenSSH, right? We use that. So you want to disable port forwarding, so you cannot just connect and then port forward traffic out of the system as a proxy. Disable X11 forwarding or anything else that you may not need that could pose some sort of security risk. Also, you can rate limit people trying to break into the students' container or inside the host account for the students, and other common things. This is kind of boring, but least privileged user and run a host or host intrusion detection system like OSSEC on the box so you can monitor it. Right, common sense stuff. Working with ISLET now. So this is what it is as the stack. This is not completely accurate. I just made it really easy to stack stuff on top, but it gets the point across. So we have the user at the top, OpenSSH, GNU Make, SQLite, Bash, Docker, and then Linux. These are the components of ISLET. And you'll notice that all these are these components, just nearly everyone will have on a Linux system, right, including Linux. So Linux kernel anyway. So in a lot of these, the packages for this will be very easy to install. It makes it very simple. So if you want to run your own ISLET system, this is for the instructors or the admins who will be doing training, or anybody that runs an organization where training needs to be done or handled to teach some sort of software that runs on Linux. Well, you need to have Linux, right? So these containers only work on Linux at this time. So you also need to have a 64-bit edition of the Linux kernel. And that is because Docker requires that. It's just a requirement for Docker, and we rely on Docker, thus we need to do that. Also, if you're going to install this system, I highly recommend a Debian-based system. That's where it's been, because that's where I've done all my testing. I've tested on some others, but it's been a long time now to keep it up to date. So if you want to have it and make it easy out of the box installation, then use a Debian system. And I use Ubuntu for it, yes. No, I have not. But it should work just fine, because that's Debian-based. Yeah. So we should talk later. I think you should use it, Bill. So, all right. Anyways, so if you want to install ISLET, you just do git clone and this GitHub repository, and it's installed, and it'll pull down the software, and then all you have to do is run the configure script in the make targets, and I'll show you that later in the demo section. So configuration and workflow. So we have, let's talk about that three-step, briefly make that three-step process. Well, you have a global configuration file called islet.conf. You set everything else that you want to be passed to all the users, and some administrative stuff, like how many login authentication attempts before we kick the user out, stuff like that. Also, there are per image configuration files. So if you have a training environment and you want to teach somebody how to use volatility, you have a volatility.conf file, or whatever you want to call it yourself. All it does is just tell it as a variable and say, point to this Docker image, right? And apply these resource constraints to the user. So CPU equals 1. For example, if you want to allocate one relative share of the CPU to a user, or memory equals 200 megabytes. Very simple configuration. And that just says when the user launches that volatility image and turns it into a container, this stuff will be applied to it. And all you have to do is, once you create these simple text files, is drop them in the etc islet directory, and then you're done. That's all you have to do. Next time the user connects, that configuration should be ready to go. So, other things. So some of this is in development still. I need to do more testing on it, but they did work the last time I did test them. And that is the ability to port forward stuff in containers to the user so they can access things that are not so much just bound to an interactive shell. For example, if you want to teach some sort of web interface training, I don't know, if you want to teach somebody how to use Snorby, this is where for my NSM, we want to use a Snort Circata event-based web interface. You can use Snorby, it's a popular one. So how do you do this? Well, what we do is every container would run its own instance of Apache or whatever in Snorby inside it, or the Rails environment. and the user would connect to the ISLET menu. They'd actually come to the shell, they have internet interactive access, and then the shell would be like, oh, hey, you can connect to us at this port, and they can go to their web browser on their laptop or workstation and type in that URL with the port number, and then they'll actually have access to that Snorbee. So you can have 1,000 versions of Snorbee running for each user. So if one breaks one, or messing with wants to hack on it, whatever, it won't affect those of everybody else. So it's really nice. Also, for GUI-based applications, you can use DirectX 11 now. I'm going to figure out a way to do something a little bit better than that, but it does work. Easy update. So also, for the design, to make everything as easy as possible, if you need to update an ISLET system, you just run make update and you're done. Very simple. So this is the demo portion. And I actually didn't get to test this last night in the hotel room because Wi-Fi was so poor. It was absolutely awful, and I'm so disappointed. But let's try to do this live, and do forgive me if I have some issues. All right, let's start with a new Amazon EC2 instance, because this is what I normally do if I'm going to do a training event. Choose the free one, will be fine. Can everybody see that okay? Do I need to increase the... is that better? Or bigger than that? Yeah, the depth field. All right, so yeah, it's taking quite a bit of real estate on my screen right now. All right, let's call it test. Test two, actually. I don't know if I test it. Select a security group. This is a standard procedure if you're creating this stuff, so we're going to allow SSH. I'll choose my key to connect to it. Okay, so at this point I can view the instances, and you can see that it should be booting. That is test 2, initializing. Let's go back to the shell. Everybody see that? Okay, I'm sorry, it's so big that it's line wrapping. I do have a multi-line file. So stuff like this, I need probably need to change this for presentation because it gets too long. But I do like multi-line file. All right, so let's do SSH test Ubuntu. That's the default user when we create an Ubuntu instance. Hopefully the IP address was this. Not quite up yet. Just a moment. Still initializing. Alright. Seems to be up. A little slow. Bingo. Alright, so let me increase the font size for that. Hopefully that's better. Okay, so first of all, what we need to do is we need to get Git, right? So, well, I guess before that, we need to update our package repo list. All right, now what we're going to do is install Git. Because remember, the code is not stored on GitHub, so we need a Git client to actually pull it in. All right, so at this point, we can actually clone it. github.com/Schipp/ISLET. Cloning. All right, go in the ISLET directory. See a few things here. Let's run the configure script first off. Okay, so it tells us a few things. We're missing 3 things. Those things that are marked no in red. We need make, and we need SQLite, and finally we need Docker. So let's go ahead and install SQLite and make. Okay, they're installed. Very simple. Let's run that same script, and you can see finally we just need Docker. Now I do notice that I say Docker not found, try this command. And this is just to be more helpful. So if you're on a Debian system, you should be able to use this to actually pull down the Docker repository, their package repository for Debian systems to install Docker. So you have the latest one. They actually keep theirs more up to date than is currently in the tree for the base Debian and Ubuntu distribution. Or yeah, in distribution. So we're going to do that. And you also have the latest features. Make install -Docker. go with installing Docker now. Well, right now it's pulling down the packages, but it's ready to install it, or actually adding the PPA. But soon we'll pull it down and install. You can see it's doing 1.6 and we installed that and actually just released last week. Alright, so at this point, we did the configure script again, and voila, everything is yes. We're happy. So now we type make. And that looks kind of ugly because it's so small on the screen, but there's a number of make targets, and the main ones we want to focus on are make install, and Docker config and user config, and possibly security config. So we're going to do that. So remember, this is for a Debian or Ubuntu-based distribution. If you want to be a trainer, this is simply all you have to do to set this thing up. So now what I do, type make install. Boom, it installed all the software. Next, what we're going to do is make user config. This is just an easy way to create a user called demo for your ISLET installation, with the password by default as demo. Then we do make security config, and that just sets up SSH for you, and provides some security controls to SSH to disallow tunneling through, etc., to prevent people using this as a proxy or a point to attack other hosts. And finally, that should be it. Yep, user config, security config. There's also a few other things here like IP tables config to actually configure rate limiting on the host. And there's a few other things like make package if you want to package this up. But we don't have any, at this point, we don't have any images or anything to work with, any training environment. So to show how we can do that. So this, open the terminal window, increase the size here. That's visible for everybody. SSH. So remember, we created that demo user account. And now we're going to go into the ISLET system. Aha! So here's the first interface you'll come across. This little logo and a countdown. Press OK or press a key if you want to continue. And then it's going to ask if I'm a new or existing user. And I'm going to say I'm a new user. My name is John. Last name Schipp. So John S. On the password, and there I'm done. So I just create a new user account, but you can see it says no configuration available. There was nothing I can use to launch into it anymore. So we need to create that. So going back here, I was kind to make this very easy so that there's a number of environments I already created that you can just pull down automatically. So to do that, first of all, if you were doing Bro training, there's one built in the miscellaneous targets here. You can do make install Bro live config, and you have a version of Bro and container ready to go do training on Bro, which is a popular network security monitoring tool. So what we're going to do now is we are going to show you a hidden make target that you can use to, because I won't leave the menu too long, to actually install a bunch of sample configurations. So this one right here, make install dash sample dash NSM dash configs. There's a lot of targets that are hidden. So yeah, all I did is install some ISLET configuration files. And the way this is set up, that if the ISLET configuration files points to an image name that's actually located in the Docker registry, it actually pulls it down for you. So you can see now from this, we just take a look at the ISLET directory that we have those configuration files. You can take a brief look at one of them. Let's take a look at Bro Live for the Bro training image. And you can see at the top, it's very simple right now. You can see at the top it says the name of the image. That's where it's going to pull down. So if it's not installed on the system, it's going to use Docker pull to actually pull it down to Docker Hub, which is the official Bro training image. Also, there's a number of other variables like the number of days that the training environment will be, or the container will live for. So after this, if there's a training event that spans 3 days, we would set this to 3. So that after the 3rd day, then all the account stuff is deleted, the containers are gone, it's not going to continue to build up disk space. And if you have the class, you would set it with the link to the class, etc. And a number of other options that aren't too important, but you got the CPU, RAM, easy stuff we talked about the resource constraint prior. So that's the configuration file, very simple, and well commented. So at this point, we go back to our config. I'm sorry, to our menu, to ISLET itself. So now I'm an existing user. Authenticating back in, success, and here you go. There is the menu for the configurations. So I want to run Bro now, right? So I want to hit number 2 for Bro Live. It says image not found, trying Docker Hub. because we didn't actually install an image manually or create one. We're actually going to pull it down from the official document repository for Bro. And it's a large image. I'll probably show a different one. It's like 1.6 gigabytes, I think. So I apologize for this slide delay. Okay, so with that, you probably want to know what a Docker file looks like. How do you create your own environment? So to show you how easy it was, I got a few online. Actually, we probably just got a web browser. Nope. Okay, so for the Bro stuff, let's take a look at this one. So this is a Docker file. Essentially, what it looks like at a high level, it's kind of like a bunch of commands you run in a shell to install your stuff, right? So I just say, hey, I want to use the base Ubuntu image. So I'm going to pull down Ubuntu. It's going to install everything in the commands below on top of it, and that will be my container. So I set a few environment variables to make things easier. But if you look at it, you can say, oh, apt-get install or apt-get update, right? Common things you do to install new packages on the system. So then you install all the dependencies and tools you need for the environment, Git, TCP dump, build essentials, etc., and you pull down Bro and compile it. So if you ever install packages on Linux or compiled software from source, you follow the same procedure. You just write it in a little file, so it's scripted in a way, and you say Docker build, and you point it to this file, and it creates an image out of this file, and you just get to name it, right? So it's very simple. It's so much easier than working with virtual machines, right? So let me give you one example that was a little bit long, a little bit more advanced, because there's a lot required to build Bro. But this, I think the C one. So we had a Linux user one night. We had a guy that wanted to do a C course, and he just needed GCC, right, the new compiler available. And in 5 minutes before, so that I was getting ready to get off work, and then the actual meeting was like an hour later. He's like, okay, can you do something about this? Oh yeah. So what I did was I literally just created this in less than 5 minutes, so fast, just to get a GCC, so all the students could learn how to use the GCC compiler and program in C. So literally, all I did was update, install build essential, and then a few other tools. This is pretty much the only one that's required, because that's what actually has the compiler and stuff. And then all these other tools to make it easy, like a bunch of editors. People might not know Vim, so you install Nano and Emacs, other things that you might have a preference for. And essentially that's it. Everything else is just security stuff and to make things easier. And that was it. So it took about 5 minutes to do. This is 6 lines, right? The meat of it's 6 lines. We had a training environment ready to go. Okay, so Bro's done now. It says enjoy yourself because it actually finished. Take a look down here at status. It downloaded the image, and it says the training materials are in /exercise. There's a little message of the day you can put for each container or each configuration. So now I have a shell with Bro installed, right? So I can run Bro-I on the loopback interface. That's actually disregarding that security feature that I have by default. I need to fix that, but you can see that the loopback is here because I disabled networking so that users can only just use Bro locally, and they typically would use it by Bro-R, and then you read in the PCAP file, right? You read a trace of network traffic, so you can do forensic research or and some research on it. So, and then the trainer, for example, would just drop all that information in the exercises directory. There's nothing there now because this is not prepared for a training environment, just to show you. They would do Bro-R, for example, as exercises, and then training.pcap, they run it in there, and then you go follow along with the instructor to actually do the training. Makes it really simple. And the students that I've worked with, they actually have this in the classes. They like it a lot. It's a lot easier than what they've had before. Okay, so that's that. That covers the demo of ISLET. So let's go back to the presentation here. Oops. Okay. So now, if anybody wants to try it out, here's a special for you guys. You can go use SSH demo at ISLET1 or islet2.johnschipp.com, and you can play with it yourself if you're interested. If you're an instructor and you want to learn more about it, do try it out. So, finalizing this, the roadmap. Well, this is really funny. But actually, I actually did it. I have it working. You can run your Docker in a Docker. So there's a make target called make install dash contained, and it will install ISLET in a Docker container, which from that container, Docker is bind mount it, and then you can launch containers within that container. Sounds complicated. It wasn't that bad, but it's kind of cool. So that way you can do, there's very little modification to the host. Did someone say something? Okay, didn't know if you had a question or not. Anyways, and then finally, I worked on 2 papers for this. One we finished and we turned it into the EXCEED conference, the Extreme Science and Discovery Environment Conference, and then another one was at I forget the name, a conference in South Korea. Looking to hear back from those. Also, I plan to port this to other jailed or container runtimes, such as FreeBSD's jails or LXC on Linux, just so it's not so bound to Docker. And there's support for other things, should something happen to the Docker. Also, if you're interested in security, you do reviews, audits, or penetration testing. This needs to be tested. I try to do a little bit myself, but haven't had a whole lot of time to work on it. Also, I plan to rewrite it in Golang or Python. Right now, it's just a big bash script, actually a few big bash scripts, so it needs to be rewritten. And one of the big things that I would like to have, and I had a request from a student, was the ability to export your container, take it home, right, and be able to run it on your own machine. So with virtual machines, you'll know that this is the advantage right now, is that you have a virtual machine, they pass it out at the conference, and you have it on your machine forever, right, so you can play around later if you want. This is not the case for ISLET now, but it will happen, and I've got an idea of how we can push it up to S3, for example, so shoot an email to the user, and they can pull it down and run it. And the last one was make it distributed so that you can teach MOOC, the massive online courses with it, with more than 1,000 users. So I need to find a way to scale it horizontally across multiple nodes. If you're interested in contributing, you can send me pull requests, patches, feature requests, and file issues on GitHub. And do tell me what you think if you do use it. Finally, testing and development. If you want to actually do development and make it really easy, there's a Vagrant box. You can get clone it and Vagrant up, and then you have ISLET ready to go that you can perform your development on. If anyone needs to reach me, johnshipp@gmail.com is preferred. Find all my other information on johnshipp.com. I'm on Twitter @JohnShipp, and you can always hashtag ISLET if you're interested in ISLET or have questions regarding it, or you want to promote it. And keep your stash on Freenode. Oh, that's been with me, bro. It's been with me since high school, I think. I don't think I want to change. This is funny. But it is security, right? So in prisons, you know.
So you say you want me to use this, right?
Yes, I'd like you to use it.
You don't have the infrastructure.
Do you what? You guys don't have the infrastructure? You don't have a spare host.
Now, it'd be hard to do it in our environment.
Okay.
But I appreciate it.
Yeah. Just so you know, it's not that hard. You just need one spare host.
Yeah, we don't have these.
Okay, just throw it out there.
Computer.
Okay. You can run it on your laptop in a VM. Just throwing it out there.
No, but I'm not available.
Sorry, hopefully I talk loudly enough. That's it. That concludes my presentation. All right. Well, thank you guys. I appreciate your time.